Hello people, hope you all are well and safe. Today I will be demonstrating how to write a smart contract in Solidity programming language. If you are watching this video, it is fairly obvious that you know the fundamentals of blockchain and smart contract. You can find the two introductory videos about blockchain on my channel. So let's begin. We will be using Remix. It is an online IDE for writing smart contracts in Solidity. So head on to google.com and type in remix.ethereum.org. It does not require any installations. So this is the Remix dashboard, basically where you can type in and test your Solidity code. On your left side, you can see that there is the file explorer with all the it provides some default files, and you can also have, like, you can publish your files on GitHub gist. You can also import files from local file storage. We need to click the environment as Solidity. So you can see that this is the Solidity compiler. It has the latest version 0.66. You can change the versions as per your requirements. In the language, we need to select Solidity as the programming language, and let's keep the compiler version as default. So this is the compiler, and we also have the deploy and run transactions. So here we have to set the environment as JavaScript virtual machine. You can use Web3 if you are comfortable using that. For now, we will keep it as JavaScript. Then we have the accounts. Here you get like a list of different accounts with 100 free fake ethers, which you can use for testing. This is the gas limit, which you can change, and this is the transaction values. So here basically we deploy the contract, and for now we don't have any contract, but we will deploy and run. And this is the static analysis. So it basically keeps a track of the economy of your smart contract. It will tell you any better measurements to do. This is the unit testing. So here you can upload your own test cases from localhost or browser. You can generate the unit test cases. And these are the plugin manager. So this is where you can add and remove plugins. So for now, these are the basic ones which we need to keep. You can deactivate plugins from here, and there are a lot of different lists of plugins available. And yeah, so you can also have like a debugger. You can also, this Remix also supports Viper. Viper is another programming language for for smart contracts. And so let's begin. So this is the console. So this is where basically you can see the transactions and the output. So let's begin by creating a new file, and this is, we can just name it as SmartContract.sol. So this is your new contract. So let's start typing in some code. Pragma Solidity. So 0.422 and 0.70. So this is basically the version of Solidity where the smart contract will run. This is the compiler versions compatible. A smart contract for creating users and storing their records. So I'm just writing some documentation part. So 004, that's my name. Yeah, so contract, smart contract. So you should have the same name as the file name. And we are creating a user structure. So this struct is basically, if you have done programming in C++, it is similar to the structure in C++. Address. So this is another data type. So this will be the user ID. So it is a wallet address of the user. This is basically a data type of hexadecimal string, which gets stored on the blockchain. Then string username. So this is the unique username for each user. So these, I'm just basically mentioning the data types which are present in Solidity. uint is another. So uint age will be the age of the specific user. So uint has like 256 and 512, so you can define how many bytes you require for storing the integer. Let's create another structure called as record. It will have an address, can be of the file ID. So each and every file will have a specific address or ID, unique ID of its own. It will be stored on blockchain, and we will have a file name, so a string file name, and so you can store like a file name or a description. Normally, we do not store files directly on blockchain. If you have some idea about blockchain, we require, because it is open source, everyone can read the code and the data. So we need to either encrypt it, or we need to store the file on IPFS, and then we can view the file on the blockchain. We can store the hash of the file on blockchain. Bytes 32 file type, so it's like a PDF doc. We can store a medical report. And uint, so it's the timestamp. So this timestamp is automatically generated whenever we add a data on blockchain. And a bool, so bool is like a boolean, so I'm just storing it's like as approved. So basically this is where the owner will actually give the access to the file. So if the owner approves it, then only the file will be shared. So this is the basic structure created. So these structures are private to the contract, and you can define public or global variables outside. So uint public, we can add like total users, so that will be 0. So this is a public, like a global variable. It can be accessed outside of the smart contract. Let's define an internal variable. So uint internal total records, we can say. So this is a variable which is defined internally, so it cannot be accessed outside the smart contract. This is a mapping. So mapping is a keyword. It's actually a function. Mapping string is record. So this is also an internal structure. So every file record will be mapped to a string, because we need to have, so here I'm considering the file name to be unique. So the string will be the file name, and every file name will be mapped with the record. Similarly, we'll be mapping address to the user. So users will have all the lists of all the users in our registered in our smart contract. And similarly, every user can have multiple file records. So the user's address will be mapped with an array of records. I'm just adding like a description, so that the viewers who can access the code later, they can understand what is written there. So this is array of lists of all the records, users records. Okay, and it's each user's record. And now let's start writing the functions. So the first function would be register user. So function register user. These functions also follow the same syntax as we have in different programming languages. String. So these are the input fields. Memory. So memory is another keyword which basically tells the compiler that the data type is a string or an array or an address. We defined this method as public so that it can be accessed outside the smart contract. User storage u equal to users of message.sender. So message.sender is an important keyword. It is basically the user which is currently calling this function. So we will get the entire structure of this current user, and this is a little bit weird syntax. So basically here I'm checking that the if the user already exists. So kekak is um, basically it's like an algorithm which is used to convert strings into hexadecimal values. So I'm checking if an ABI.encode packet, that is another, we can say like a pragma or like a library which is provided by Solidity. And require is a special keyword. So require is something like an if else condition in other programming languages, which basically checks if the condition is true, then it will move ahead. If it doesn't, if the condition is not satisfied, then it will return. So the transaction is not completed successfully. Yeah, so basically checking if string username is not empty. So that's the entire syntax, just to check if the username is empty or no. And if it is not empty, we will check if the message.sender is equal to the user.user ID. So if the user ID already exists in our storage, then we will revert the transaction as already registered. Else we will create a new user. So users of message.sender equal to user. So this will be the name of the structure which we have defined on line number 7. And we will pass in the message.sender. So when we are creating a new structure or we are adding a new value, we need to pass in each and every data type and variable which is defined. So message.sender, comma, name, comma, age. And we just do a total users plus plus. So we are incrementing, keeping a count. And I'll just write the commenting part. So if user ID exists, then we will revert the transaction to already registered. So basically you can catch this error in your actual code, and you can like do some error handling there. And add user, so add user to list of all users, and that's counter plus plus. So this is the register user function. Similar to that, now we will have to write a function of getting the user. So for now I'm writing here it as get username. It will be public, and it will be view and returns. So there, if when you're writing something to the smart contract, there are ethers or the coins are consumed. But when we are calling something or just retrieving data from smart contract, we will just return the data. So it does not consume any ethers or coins for transactions. So that is the keyword view. View basically only can return the data. You cannot write write to the data. It will only read the data. So this will return the current user's username. And let's now try running this code. We will just move on to compiler. So this is the Solidity compiler. Just we need to enable optimization and hide the warnings. We don't want to see the warnings. Oops, and there's an error. Okay, so this username, okay, this should be the name. So it should be the input which we are passing to the function. And yeah, it is compiled. We move into the deployer and running. So that's the deploy and run transactions. So we select the first account, keep the gas limit as same, and we click on deploy. And in console, you can see that the smart contract has been deployed. So you get the transaction ID, a hash number. So yeah, so that is the transaction cost, and that is the contract address which you get. You will require this address when you're adding this contract to the code. That's the transaction hash. And here you can see that the smart contract has been deployed and these are the publicly defined methods. So total users is 0. So we call the smart contract the total users. Let's register. So Surit004, that's my name and age. And when I click on register user, it has been registered. The transaction is successful. Every transaction has its own hash. And when I do this transaction, there are a few ethers, or there are a few coins which will be consumed. So you can see that the age has been converted into a hex value there. And we click on get username, you get the username, and the total users is 1. So these are the two functions which have been successfully deployed, and it is working. So now let's start writing another function. So we will create a record for the user. Before that, just a change. We need to change this to address owner. We don't require the address of the file. We require the address of the owner of the file to be stored in the structure. And let's change bytes 32 to string because it's difficult to write bytes 32. Bytes 32 is a hexadecimal value. So this will be a new function, add record. We will have an input. We need to pass the file name, the string, memory, file type, and that's all. And this will also be a public function so that it can be accessed outside the smart contract. And here we will require the mapping, so file data of file name. So we are adding a new record based on the file name. File name should be unique. If the file name is same, the data will be overwritten. So record of message.sender, comma file name, comma file type, and block.timestamp. So block.timestamp is a keyword which basically returns a Unix value of the current timestamp. Let's just say the approved value is true. So each and every file is a valid file and it will be shared. So I'm just writing here as true. We can write a different function where we can manually change the value for every file for as it will be true and false. So user files of message.sender. So this is the current user. Dot push. So user files is an array, so we use the push method as seen in other programming languages. File data of file name, and we do a total records plus plus. Next, we will add another function, get record. So we will pass in the input. And so basically when we pass in the input, we should get the file name and the file type and all the other details of the file record. So public view returns string memory file name, string memory file type, and we can also return the timestamp. So uint timestamp. Timestamp is an integer value. So we will check if message.sender equal to the file data of input dot owner. So here we are checking basically if the file's owner is the current user himself. Return file data of input dot file name. So keep a check here that the file name is the variable name of the structure and not what we are returning. File data of input dot file type. So basically n and file names n will be capital and file types t will be capital. File data of input dot timestamp. So that is what we return. Else we will just revert back and just say you unauthorized access. So basically the user is not allowed to view the file. He is not the owner of the file. So I'll just type in the comments. The current user is not owner of the file hence cannot access. And here check if the current user is owner of the file. So let's try running this code. So you need to again compile the smart contract. Now, before compiling, we need to delete the deployed contracts because we are compiling it again. So we need to compile the smart contract again and click on the deploy. We will select the first account. Again, click on deploy. The contract is deployed. And we can see that this is the transaction hash. Transaction is mined and execution succeeded. So here are the methods. So let's register again. So here you can see that the total users we can see, but we cannot see the total records because it is an internal variable. It is an internal keyword used there. So it cannot be accessed outside the smart contract. So that is the use of internal keyword. So register user. I did that again. Get username, it's working. Total users, that is working. And now we will add a record. So first input is the file name. So I'm just adding my report and it's a PDF file. Add record, and that is also a success. So this is the address of the user who has called the function. So this is 22C73, and you can see that ethers have been consumed 22C73. So now we try to get the record. So get record my report, and you can see that you get the file name and the file type and the timestamp. So it is a 256 bytes integer timestamp which we receive, and the smart contract.get record, that is also, it works. Now let us consider that we are another user. So this is, we switch the account. So this is a different user. This is a different wallet address. And we try registering on this platform with this smart contract, John Doe 28. And click on register user. And the transaction is successful. And get username, I get my username. Total users is 2. Now I try to access the report file of my report file via this account. So get record my report from this account, get record, and there is the error, VM error. So the transaction has been reverted to the initial state, unauthorized access. So this is the error which has been caught. We can handle this error by giving the access, by sending a notification to the user, giving the access to the file. And that's how a smart contract works. And this smart contract can be then deployed on your application, and we can call these functions as we call any other functions in other programming languages. Clicking on the smart contract, we can publish it on Swarm, we can publish it on IPFS, and we click on compilation details. So this is the name of the smart contract, and this is the bytecode, which is important in some applications. You need to add this bytecode so that the smart contract can be accessed. This is the ABI. You can copy this value to clipboard as well. If you are using Web3 deploy, you get a ready-made piece of code. Web3 is another JavaScript framework which is used to write Ethereum smart contracts, and this is the gas estimates. So it has all the cost of execution and the total cost in gas values. So, and we have all the methods and their input parameters. If you want to optimize this smart contract and check how it can be better, you can use the analysis tool. Here you can see that This shows like how you can improve the gas costs. So it shows that smart contract register user is infinite the gas cost. So please avoid loops in your functions or actions that modify large areas of storage, clearing and copying arrays in storage. So we can modify, optimize this. And when you click on the home dashboard of Remix, there's the documentation link. So it is a pretty well written documentation, I can say. If you have any other doubts or questions, you can refer the documentation if you want to write some more complex smart contracts. And this is like everything is open source and free. You can import contracts from GitHub, the files, IPFS is also another important part of blockchain which can be used, message sender, message value. So it's a pretty well written documentation, I can say. And if you have any other doubts about this code as well, you can comment down in the section below. And this code which I wrote today will be in the description below. It will be a link to the GitHub, and you can copy the code from there. But I do insist on watching this video. And thank you guys. Thank you for watching. Like, share, subscribe, and
keep your code simple.